So as we just saw, sucrose does not have a hemiacetal group. So let's fill this in here. Sucrose is a non-reducing sugar. Sucrose does not cause Benedict's reagent to change colors. Okay, let's go and look at some polysaccharides. Let's zoom in a little bit here. Okay, so a polysaccharide, poly means many, saccharide sugar, so many units of sugar that are bonded together end to end to end, and these are normally thousands of units long, so I cannot draw the whole thing on here. So instead, I kind of did these brackets with this n, where n could be some big number that I'm going to say that repeats on and on and on. Anyway, you need to know that it's thousands of units long, and on the very end, you have one hemiacetal group. Most of it, and this is thousands long, is non-reducing. Most of the sugar units do not react. So because there is a hemiacetal only on the end, and it is mostly non-reducing, it will be negative with Benedict's. Even though it does have one hemiacetal, we call this the reducing group or reducing end. So it does have one reducing group, but thousands that are not, so it doesn't react. So you'll test starch. If starch is broken up, if it's been chopped up in some way, then you may get a positive test. And our starch should be pretty fresh, and it should not test positive unless you do something to break it up. So, and we will do some hydrolysis. Hydrolysis is the reaction where you break up the starch. So we got a really long starch molecule, and if we perform hydrolysis, and we could use two different catalysts for this. We're going to try using sulfuric acid as a catalyst or amylase as a catalyst. If you do one of those two things and it gets broken up, you incubate it, and then if you test this solution, this would test positive.